Working on a GE side-by-side refrigerator. Issue is the freezer wasn't cold, so we found a big puddle of water on the ground. Everything melted in there, and the fridge wasn't cold either. So let me go ahead and plug it in here. I got some stuff plugged in, got some stuff apart. The compressor's not turning on, but the cooling fan is. So if you look down in here, the fan right there is on, but the compressor's not turning on. And there's your main circuit board, which goes to your compressor, which goes to your inverter, which I have a part there. So what I want to look at, I did an overview on the board. Nothing looked bad. The fuse down there is not blowing. So, and I know that because I got power to the whole entire fridge, right? Because that fan's working. But the compressor's not turning on. So if you look at the wiring diagram here, here's your main control board, which is this guy. Sorry, it's kind of dark in here. If you look at your compressor, you got your 3 windings, your inverter, you got your red and white wire. They go up and they go into the J15 and J15.1 and J15.2 connector. That should be put now at a RMS of 4 or 4 to 6 volts. 6 volts meaning it would be, or the higher the voltage between 4 and 6. Usually it's about 5 and some change. That means it's demanding that compressor to run more constant because it's PWM or pulse width modulated. So if you hooked it up to an oscilloscope, you would get a square wave. Of course, when we hook up the oscilloscope, we're going to probably get, I don't know, 8 or 10 volts, because when we're doing it on a multimeter, DMM, it's just going to be RMS, means square, takes an average. So, first thing is the J15. You can see it right there, the white on the left and the red on the right. We're going to put a positive, negative leads in there. And if we got the signal coming from this board, that sends a signal to the inverter, which is that black box down there, which turns the compressor on for your 3 windings in there. Those 3 windings right there. And goes through the inverter. So now I'm going to go ahead and check that. So now, got my DMM digital multimeter hooked up. I'm going to go positive, negative here. I'm going to probe in, not to bend the pins. If you look at the DMM, again 5.1 volt. I got a good connection. 5.1, 5.2 volts, right? That's good, meaning that it's sending the proper signal. That tells me this board is sending the signal to the compressor. All this other circuitry on here is for ice dispenser, the temperature control, but I don't care about that. The compressor's not turning on. Sorry, I lost connection there. Right there. So now, I'm gonna hook up my oscilloscope just to show you the square wave. Take a look at that. You can see my oscilloscope there. Taking these 2 probes here, doing the same exact test. Watch the scope channel there, or the screen. I should get a square wave, and I do. It looks like it's 10 volts, 0 to 10 volt square wave. Of course, RMS is gonna be around, a little bit, around half, a little bit more than half. So we got a good square wave. So that tells me that this main board over here is good. It's sending a signal out. So that white and red wire go down to this inverter board down here. You can check it down here, and I already did. All that's good. So now what I want to do, so now I can check, and I already have, but the same white and red wires right there, I'll get the same signal. I'll hook it up just to show you. So I got it hooked up to my oscilloscope. If you look at it, you got your same square wave. 0 to 10 volts. Of course, if I hooked it up to my DMM, I get the 4 to 6, but we're getting 5.1, 5.2 volts RMS root mean square. So that's good up to that. So the wires we just checked there are, here's your compressor, 3 windings is the red and white. They go all the way up to your main control board. We checked the signal. This board should be sending out a 5 volt signal, which it is. Well, then it goes through the inverter. So we got to, I'm thinking the inverter's bad, but we're going to check these windings here. Since it's an inverter type compressor, all 3 of these windings which are those pins there in the center of the screen, those 3 round pins. We're going to check them for continuity. All have the same exact resistance. They're excessively high or excessively low, that means they're shorted or it's an open circuit. I think it's like 4 to 10 ohms or something like that. Got my DMM on ohms, and I got one of the leads there. I'm going to touch the other one, and I got 6.6, 6.5 ohms. And check the back one there, 6.4 ohms, so that's good. I'm gonna go ahead and move this and keep checking all the way around against each other and make sure we're all good. All right, so all 3 of those windings are good. We're 6.4, 6.5 ohms. That means the winding and the compressor are good. So it's telling me that this inverter box is what needs to be replaced, because it's getting the 5-volt signal from the board, but it's not sending a signal out of it into the compressor. It's pulse width modulated because there's something wrong in the board. It should be coming through that connector there. I'm gonna do another check here. So on this diagram, like I said, you got your white and your red, which is your signal from the control board, which is that connector there. It goes back to the inverter, which this is the inverter. Well, there's a ground wire going to chassis ground, and then you got your other wires here. You got a orange and a black. Well, if you look on here, your orange, right down here, your orange going into your inverter, and then your black. Your black's your neutral, and your orange is your hot wire. So I'm checking those. You get 120 volts alternating current, and I got 120 volts AC. Because there's 2 power sources. You got your 120, basically your one-phase power to the compressor, which we have, so that's good. But we don't have is our we have our 120 going into this box, and we have our 5 volts going into it, but it's not coming out through these 3 wires here, which is black, blue, and brown, which are those white right there. Black, blue, and brown. There's something wrong with the inverter assembly, so this is what it needs to be replaced. All right, so like I said on the diagram here, the black, blue, and brown goes to the compressor. All the windings are good. 0 to 10 ohms. We got 6.4, 6.5, so they're all good. Goes to the inverter. Black, blue, and brown. If you look there, black, blue, and brown. So, like I said, the 120 is going into this. The hot wire good. The neutral wire is good. The 5-volt reference from the main circuit board is good. It's just not spitting it out of this. Now we could hook up the oscilloscope or DMM and measure frequency. Frequency meaning that it's pulse width modulated in a square wave, because that's how you control the speed of this compressor right here. Control the speed of that. That's how this board does it. But we already know this board is bad. Better process of elimination. We could possibly take the board apart and fix it, or we could just go to the parts store, appliance parts store, and buy a new one. But again, everything else, when you plug it in, this fan was spinning for the condenser down here. We're going to go ahead and clean that out some more. But that's your condenser down there. All this other stuff's good. We just need a new inverter, and that'll fix this GE side-by-side fridge. Model number GSL 25JF. All right, I got the new inverter in. This is the old one. If you look at the specifications on it, inputs 115 to 127 volts, 50, 60 hertz. Outputs 230 volts, 53 to 133 hertz. So it changes the frequency and the hertz there to control pulse width modulation. In other words, how fast the compressor's running. Fans on. The compressor's on. I can feel it running. It's all wired back up. So that's a fix for this refrigerator.